Okay, this is practice 6.5. So this is conditions for rhombus, rectangles, and squares. This is the assignment we got on Thursday, December 13th. Okay, I told you guys we weren't going to do 1 through 5. You guys only had to do 6 through 19. That was so you would have enough time to finish. I don't think we did. Any of the classes had enough time to finish. So I'm just going to go through the whole thing. So if you want to skip ahead to 6 through 19, the parts you had to do, that's fine. But I'm just going to go through 1 through 5 relatively quickly here. Now, the question is asking, can you conclude that the parallelogram is a rhombus, a rectangle, or a square? Explain. Okay, so we know, again, parallelograms are quadrilaterals with 2 pairs of parallel sides. Rhombuses are parallelograms that have 4 congruent sides. Rectangles are parallelograms that have 4 right angles. And squares are parallelograms that have both 4 congruent sides and 4 right angles, because a square is both a rhombus and a rectangle. Okay, number 1, we have this diagram, and then we have, to start, identify the congruent figures marked in the diagram. So again, we have diagonals that are bisected. So those are diagonals being bisected. So they have, I guess that's what they're writing here for us, is the diagonals will bisect each other. And we know the diagonals intersect at right angles. Okay. So if one's a right angle, they're all right angles. So because the diagonals bisect each other, we know that we have a parallelogram. But because we also know the diagonals intersect at right angles, we can say it's going to be a rhombus. What are the properties of a rhombus? Is that the diagonals are perpendicular to each other. So again, on your reference sheet, it says diagonals are perpendicular. So perpendicular means that they form right angles. So if we have a right angle, we know the diagonals are perpendicular. If we have perpendicular diagonals, we know we have a rhombus. So this figure is going to be a rhombus. It's also a parallelogram, but more specifically, the best name for it is a rhombus. The second one here, we have diagonals bisecting each other, so we know it's a parallelogram. Again, the question is asking, can we conclude that it's a rhombus, a rectangle, or a square? And explain. So we know diagonals bisect each other, but we know diagonals bisect each other for all parallelograms. And that's really the only information we're given. So we know the diagonals are going to bisect each other in rhombuses, rectangles, and squares. So we cannot conclude with any certainty that this is going to be a rectangle, a rhombus, or a square, because in all parallelograms, you have the diagonals bisecting each other. And that's the only property we see displayed in this diagram. Okay, number 3, again, just like number 1, we see a right angle. So the diagonals are perpendicular. The diagonals are perpendicular. We have a rhombus. That is a unique property for rhombuses. Diagonals being perpendicular is a unique property of a rhombus. 4 and 5, a parallelogram has 2 pairs of adjacent sides that are congruent. So 2 pairs of adjacent sides. So if we draw this out, we have a parallelogram. These are 2 adjacent sides. And it's saying that 2 pairs, so the pairs of adjacent sides. So here's a pair of adjacent sides. Here's another pair of adjacent sides. So there's 2 pairs of adjacent sides right there. But it's telling us that the 2 pairs of adjacent sides are congruent. Right? So if the 2 pairs of adjacent sides are congruent, all 4 sides are congruent. If we know all 4 sides are congruent, we know we have a rhombus. A rhombus is a parallelogram that has 4 congruent sides. So 4 is going to be a rhombus. 5 is saying a parallelogram's diagonals form 8 congruent angles at the vertices. So here's a parallelogram. Okay, we're forming 8. Well, this isn't the best drawing. We'll work with this drawing, and then we'll make a better drawing at the end. It's saying our diagonals. So here's our diagonals. Let's draw them in. They're going to form 8 congruent angles at the vertices. So here's our 4 vertices. Right, these are our 4 vertices. It's saying that the diagonals are going to form 8 congruent angles. That means that all of these are going to be the same. The only way these 4 are all going to be the same, right? Because we know consecutive angles, so we know this angle and this angle are consecutive angles. The only way for those angles to be the same and allow for these smaller ones to be the same is if they are right angles, if they're 90-degree angles. All right, we'd have to do 180 divided by 2 to get 90, so these would both have to be right angles, and then these would have to be right angles. So the only way, if we want all 8 vertices to be the same, we have to have a square. Right. In order for these to be the same, we need to bisect, so we need a rhombus, right? In order, we need to have a rectangle because we need to have 90-degree angles at each one. We need this angle to be congruent to this angle, to be congruent to this angle, to be congruent to that angle. So when we split them in half, all those half angles are the same. And then we need a rhombus because we need the diagonals to bisect the opposite angles. Okay. So if we have a rectangle and a rhombus, we have a square. And the 8 congruent vertices are going to be 45, 45, 45, 45, 45, 45, and 45. The other way we could have done this is we know the 4 angles of a quadrilateral add up to 360. We want 8 angles at the vertices to be congruent, so 360 divided by 8, which is going to give us 45. So that one has to be a square. Number wrong. It's always the wrong. Okay, algebra. For what value of x is the figure the given special parallelogram? So we have a rectangle. For what value of x is the figure the given special parallelogram? So what value of x makes this a rectangle? Well, rectangles, we know that the diagonals are congruent. So we know that if this is one diagonal and that diagonal is 5x minus 15, this is the other diagonal, and this is 3x plus 9. We know 5x minus 15 equals 3x plus 9. Subtract 3x. 2x minus 15 equals 9. Add 15. 2x is going to equal 24. Divide by 2, x is going to equal 12. So 5 times 12 is 60. 60 minus 15 is 45. 12 times 3 is 36. 36 plus 9 is 45. So 45 and 45 are going to be the diagonals. The diagonals of a rectangle are congruent. It might also be the case, I'm not really sure based on what this diagram is saying, that it's saying that these are the two sides we're talking about. Okay, but if you look at number 10, we can see in a rectangle, since the diagonals are congruent in a rectangle and it's a parallelogram, so the diagonals bisect each other. So if we're bisecting congruent diagonals, then the pieces we split each diagonal into, the congruent segments of each diagonal are going to be congruent to the diagonal, the segments created by bisecting the other diagonal. Right? Here's a rectangle. It's a rectangle. Here's our diagonals. So since the parallelogram diagonals bisect each other, so if we're bisecting, so if AC is bisecting BD, the congruent segments of, we have E in the middle, AE is congruent to EC. We know BE is congruent to ED, but since these two diagonals are the same length, when we bisect BD, we're going to split it into the same congruent parts that we split AC into. So it might not be referring to the whole diagonal here. It might just be referring to these parts, but either way, we're going to do the same steps. Number 7, we have a rhombus. We know in a rhombus that the diagonals bisect the opposite angles. So these two angles are going to be congruent. So if this is 2x minus 1, this one is also 2x minus 1. If we add 2x minus 1 plus 2x minus 1, we get 4x minus 2. So if we add these two angles together, both being 2x minus 1, and we get this whole angle right here, that whole angle is going to be 4x minus 2. We know this whole angle is 4x plus 28. Since we have a parallelogram, a rhombus is a parallelogram, the properties of parallelogram still apply because a rhombus is a parallelogram. We know that consecutive angles are supplementary, so those two angles are going to add up to 180 because they are consecutive angles because they're right next to each other, and consecutive angles are supplementary, meaning their angle measures add up to 180. So 4x minus 2 plus 4x plus 28 is going to equal 180. Combine like terms, 8x plus 26 equals 180. Subtract 26, 8x is going to equal 154. Divide by 8. What is that going to be? I think we get I'm blanking on this one. 74, yeah, we're not going to go in evenly here. 10, so 9. 9 times 8 is 72. We have 2 left over. We're going twice, that's 16. 4, 0, 5, so 19.25. X is going to equal 19.25. Is that right? 19.25 times 2 is going to give us 38.5 minus 1. So this is going to be 37.5. 37.5 plus 37.5 is going to be 75. We substitute it into the other one. We're going to get 4 times 19.25, which is going to give us, what is that, 80 minus 77 plus 28. So 85, 105. 105 plus 75 is 180. So we know we have the right answer by substituting it back in. Okay. Number 8, we have square. So we know both the properties of rectangles and rhombuses are going to apply to a square because a square is a rhombus and a rectangle. So if this is 7x, well, okay. As we saw in number 5, or we said when we have a square, we're going to have 45, 45, 45, 45, 45, 45, 45, and 45. All right, so we know the angles of a square. We know a square is a rectangle, so we know these are all 90-degree angles. We also know a square is a rhombus, so we know the diagonals bisect the opposite angle, so we know this angle is bisected. So if we bisect the 90-degree angle, we have 45 and 45. So 7x plus 3 is going to equal 45. Subtract 3, 7x equals 42. Divide by 7x is going to be 6. 7 times 6 is 42. 42 plus 3 is 45. We have number 9 and 10. number 9 and 10. So here we have a rectangle. We know the diagonals bisect each other because it is a parallelogram. A rectangle is a parallelogram. But we also know that the diagonals are congruent. So in a rectangle, since the diagonals are congruent, we're bisecting each diagonal bisects the other diagonal, which is the same length. So it's going to split it into the same congruent segments. So again, if we have A, B, C, D, BD splits AC into AE and EC, which is going to be the same lengths when we, right? So if AC was 20 and we split it in half, we're going to get 10 and 10. If BD is 20 and we split, right, because AD is congruent to BD, so when we split that in half, we're going to get 10 and 10. So we know all four of these segments here in the middle are going to be congruent in a rectangle, because in a rectangle, diagonals are congruent. So this is going to allow us to say 9x minus 9 equals 7x plus 1. Subtract 7x from both sides. 2x minus 9 equals 1. Add 9 to both sides. 2x is 10. X is going to be 5. We want to make sure our answer is right. We can substitute it in. 9 times 5 is 45. 45 minus 9 is 36. 36. 7 times 5 is 35. 35 plus 1 is 36. Here on the rectangle, again, we see the same thing. So these four pieces are going to be the same. So x plus 58 is going to equal 3x plus 10. Subtract x. 58 equals 2x plus 10. Subtract 10 from both sides. 48 is going to equal 2x. Divide by 2. 24 equals x. Substitute it back in just to make sure we did it right. 24 plus 58, that's 62, 72, 82. 3 times 4 is 72. 72 plus 10 is 82, so we know we have the right answer. So those were mostly rectangle problems, right? Oh no, there's rhombus and square in there. Okay, same thing for 11 through 16. And same for 11 through 16. All right. Rhombus. So again, we have a rhombus. We know one of the properties of the rhombuses is that the diagonals bisect the opposite angles. So we know the diagonal bisects this angle, so we know 3x minus 2 is going to equal 2x plus 16. Right, and a rhombus is only true in a rhombus, so squares and rhombuses, because squares are rhombuses too. In a square, it's going to be 45 and 45. If we don't know it's a square, we just have to set them equal to each other. Subtract 2x from both sides. X minus 2 equals 16. Add 2 to both sides. X is 18. Substitute in just to make sure. 2 times 18 plus 16 is going to be 36 plus 16, which is 4252. 3 times 18, so that's 54. 3 times 18 is 54. 3 times 20 is 60. And then 3 times 2 is 6. So 60 minus 6 is 54. So we know 3 times 18 is 54. Okay. Don't need a calculator for that. 54 minus 2 is 52. So we know they're the same. We know we got the right answer. X is 18. 12, same thing. And we know opposite. The diagonals bisect the angles, the opposite angles, so we know we are bisecting the angle. So since we're bisecting, we're splitting into two congruent parts. So we know 4x minus 6 is going to equal 3x plus 8. Subtract 3x. X minus 6 equals 8. Add 6 to both sides. X is 14. Substitute in to make sure. 4 times 14, that's 28 times 2. It's going to be 56. 56 minus 6 is 50. 3 times 14, that's going to be 42. 42 plus 8 is 50. You know we got the right answer there. Okay. Number 13. As we're going through this, I think we've done 3 of these in a row. We would be inclined to say 4x minus 12 equals x plus 2, and we would be wrong. Only in a rhombus are the opposite angles bisected by the diagonals. Right? The diagonals bisect opposite angles only in the rhombuses. We don't have a rhombus here, we have a rectangle. What do we know about rectangles? We know rectangles have 4 right angles. So we know these 2 angles add up together to form a right angle, so we know they're going to add together to be 90 degrees. 4x minus 12 plus x plus 2 is going to equal 90. Combine like terms, 5x minus 10 equals 90. Add 10 to both sides. 5x equals 100. Divided by 5, x is going to be 20. 20 plus 2 is 22. 4 times 20 is 80. 80 minus 12 is 68. 68 plus 22 is 90. So we're good. X is going to be 20. $14. This is a good problem. So we know it's a rhombus. So we know the diagonals bisect the opposite angles. So if this is 2x minus 13, this one is also 2x minus 13. If this is 7x minus 5, this one is also 7x minus 5 because these angles are bisected by the diagonal. Let me erase this for a minute, though. What do we know about these 2 angles? A rhombus is a parallelogram, and in a parallelogram, the consecutive angles are supplementary, meaning they add up to 180. So if this is 7x minus 5 and this is 7x minus 5, how do we find the big angle here? Well, we add 7x minus 5 plus 7x minus 5. And we get 14x minus 10. So we know this angle is 14x minus 10. We know that since this is 2x minus 13, this one is also 2x minus 13. So if we add these 2 angles together, 2x minus 13 plus 2x minus 13, we get 4x minus 26. We know the whole angle here is 4x minus 26. And again, since it's a parallelogram, consecutive angles are supplementary. So we know those 2 large angles are going to add up to 180. So we're going to have 14x minus 10 plus 4x minus 26 equals 180. Combine like terms, we have 18x minus 36 equals 180. We add 36 to both sides. 18x is going to equal 216. 180 plus 20 is 200. 200 plus 16 is 216. Divide by 18. Okay, divide by 18. Can't see it at the bottom there, but we've divided by 18. We're going to get x equals I want to say 12. Yep, 12. So it's going to, well, let me write it where we can see it. X equals 12. Okay, we substitute in to make sure it works. So let's sub it back into the original. So 7 times 12 is going to be 84, right? 84. 84 minus 5 is 79. So if that's 79, this is also 79. So we have 79 plus 79. Okay, and then here we have 2 times 12 is 24. 24 minus 13 is 9. So this one's also 9. So we've done something. Wait. 24 minus 13 is 11. Okay. So that's 11 and 11. So this whole thing is 22. This whole thing is 79 plus 79 gives us 158. So 158 plus 22 gives us 180. So we're good. X is going to be 12. Okay. 15 and 16. Fifteen is a rectangle. 15 is a rectangle. Right. So we know we have 4 right angles. Again, we're inclined to maybe do the same thing we did on the last problem, but since we have a rectangle, we can't do that. Okay. The diagonals only bisect the opposite angles in a rhombus, not in a rectangle, but we do know our angles are going to add up to 90. Right, so we have 90, 90, and 90. Okay, we also know diagonals are congruent. So, one second, let me. Okay, so I'm trying to think if I want to do this problem. I think maybe we should skip 15. Let me think. Okay, let's go on to 16. Let's just go on to 16. Okay. So if this one's, it's a rhombus, so if this is 2x plus 10, this is 2x plus 10. If this is 3x plus 5, this one's also 3x plus 5. Okay. So again, we know these two angles, just like in number 14, are going to be consecutive angles. So consecutive angles are supplementary. So we know 3x plus 5 plus 3x plus 5, right, it's going to give us this whole angle, and then we're going to have 2x plus 10 and 2x plus 10, so we can add 2x plus 10 plus 2x plus 10 equals what? Well, okay, let's split it up into two parts here. So 3x plus 5 plus 3x plus 5 is going to give us 6x plus 10. Then we have 2x plus 10 plus 2x plus 10. It's going to give us 4x plus 20. So we know this whole thing is 4x plus 20. Since we have consecutive angles that are supplementary, we know 6x plus 10 plus 4x plus 20 is going to be 180. So we have 10x plus 30 equals 180. Subtract 30. 10x equals 150. Divide by 10. Divide by 10. Okay, x is going to be 15. Okay, we substitute it back in. 15 times 3 is 45. 45 plus 5 is 50. So we have 50 and 50. Here we're going to have 2 times 15 is 30. Plus 10 is 40. So we're going to have 40 and 40. That gives us 80 and 100. Right? So we're going to have 80 and 100, right? Because we have 50 and 50. And then here we have 40, 40 to 80. And then 80 plus 100 is 180. We can do 15. All right. 15. Again, in a rectangle, we know diagonals are congruent. Okay. And we know the diagonals bisect each other. So like we said in the previous problems, all four of these are going to have to be congruent. I had to think for a minute. The reason I was thinking we couldn't do 15 for a minute there, but we have an isosceles triangle. So it took me a minute to think about that. But we have an isosceles triangle, opposite angles. Then the angles that are opposite the two congruent sides are going to be congruent, right? That's our isosceles triangle theorem. So 5x plus 10 is going to equal 6x plus 3. Subtract 5x. 10 is going to equal x plus 3. 7 is going to be x. If we substitute it back in, 6 times 7 is 42. 42 plus 3 is 45. 5 times 7 is 40. It's 35. 35 plus 10 is 45. So this is going to end up being a square, actually. Well, 45, 45, 45, 45, and these will all be 45. I wouldn't worry too much about 15. It took me a minute to think about it. I wouldn't worry too much about having to do something like that. But that's how you would do it. You'd have an isosceles triangle, so our base angles would be the same. All right. Got scared. I was going to not be able to solve that one there for a second. Not that that's a scary thing. It's just, embarrassing, maybe you could say. All right, your friend draws a parallelogram with diagonals the length of x and y. So let's do it. Let's draw a parallelogram. With diagonals of length x and y. So let's just say A, B, C, D. So AC equals x, BD equals y. Which special type of parallelogram could your friend draw if x? So we have two scenarios. The first scenario is x equals y. Which special type of parallelogram could your friend draw if x did not equal y? Well, we know diagonals are congruent in rectangles. So if x equals y, the diagonals are congruent. So we have a rectangle. If we have a rectangle, we also have a square. because squares are rectangles. So the diagonals are going to be congruent in both rectangles and squares. If x does not equal y, that means the diagonals are not the same length. So the diagonals are not congruent. We could have a rhombus. Rhombuses might have diagonals that are congruent if it's a square, and squares are rhombuses. So that would be the special case where it would not work. But if it's a rhombus and not a square, then when x does not equal y, we could have a rhombus. Error analysis. A classmate draws the figure at the right and says that it is a square because its diagonals are both perpendicular and congruent. What is your classmate's error? Well, his error is simply that he said its diagonals are both perpendicular and congruent. Well, did he draw any diagonals? No. Our diagonals go from one vertices to the other. So he didn't draw vertices. He didn't draw diagonals. That was his error. His error was he did not draw diagonals. He drew the figure on the right incorrectly. He did not draw the diagonals. Okay, number 17, students are planning a courtyard garden. They want the garden to be a square. These are the ones I'm concerned about because I haven't read these. So, I read the first one. I knew the first one was there, and that's why I liked it. So I said you guys can do these three because I saw the first one. But I actually haven't read 18 or 19. So I'm assuming that's what they wanted. They wanted that these are not actually diagonals. Okay, 19, students are planning a courtyard garden. They want the garden to be a square. How can students use ropes to check that the garden is square? So they're planning a courtyard garden. I'm thinking this is my first time reading the problem, so this is how I think of it when I think of it. So students are planning a courtyard garden. They want the garden to be a square. See, I've already gone back to the beginning, and I haven't got to the end yet. I'm just going back and rereading what I had already read. So I didn't even read it through one time all the way yet. So students are planning a courtyard garden. They want the garden to be a square. How can the students use ropes to check that the garden is a square? Justify your answer and name any theorems you used. So how can we use ropes? So ropes, multiple ropes, more than one. To check that the garden is a square. Well, one way you could do it is if you folded the rope in half and marked it, or someone held that spot, right? And then you fold it in half again, and you marked those two spots. You would have four vertices, the two endpoints, and then the midpoint of that one and the midpoint of the other one, right? If you had a string, fold it in half. No, that wouldn't. But if you had two of them, that would, right? So if you had two different strings, okay, you fold it in half to find the midpoint. Then you just put the midpoints together. So you put them perpendicularly. Here's one midpoint. Here's another. Right. Rather than what this guy did, see, this guy made them like this. We would make these be the vertices of our square. All right. Because then we would have a rhombus. And since all these are the same length, we would know it's a rectangle because the diagonals would be congruent. So we have congruent diagonals, so it's a rectangle, and we would have formed four right angles. Right, so how we're going to do it is we're going to take two strings, or one. There's probably many ways we could do this, but one way is we take two strings, we fold them in half, right? Fold the string in half, and then hold that midpoint. Take a second rope. These are ropes, not strings. Take a rope, fold in half. Take the middle of the rope, right, and just put them vertically, so perpendicular to each other. Okay. And then those 4 points are going to be your 4 vertices of your square. This way we know all 4 of these parts are the same, right? Those ropes are the same length. Okay, and we know we're making them a right angle perpendicular, so we know we have a square. So that's how you do 19. So this was the assignment from Thursday, December 13th. Conditions of rhombuses, rectangles, and squares practice.